Hi there, welcome back to Basic Math with Economics. In this video I wanted to go over some math tricks. And really, understanding a couple math tricks can make our analysis of economic problems much easier. So in this video we're going to talk about combining exponents, which is one of the most useful algebra tricks you could ever use in economics. So anyways, like I said, these little quick videos at the end are designed to help with some basic math tricks that we're going to use quite a bit. So in this one, we're going to combine exponents. So a couple videos ago, I gave you this right here, the marginal rate of substitution, which of course is the negative marginal utility of x divided by the marginal utility of y. And I got this complicated expression that I quickly simplified into something much more manageable. Well, what we're going to find is that when we get fractions like this, there's going to be many opportunities to simplify the fraction, especially if it's using exponents. If we remember a couple of the rules, it's going to be a very quick process that we can just knock out immediately. So let's actually go over these rules real quick. So if you remember, whenever you're dealing with exponents and you multiply the same exponent together, that they have the same base, all you do is you add their exponents together. So in this example right here, if I have x squared plus x to the fourth power, or x squared times x to the fourth power, that's the same as having x to the 2 plus fourth power, or just x to the sixth power. We can just add the exponents together. The same thing happens when we divide exponents. When you have x squared divided by x to the fourth, you have x to the 2 minus fourth power, or that just equals x to the negative 2 power. I want to say negative squared, but that's not really a thing. Another thing to also remember is if you have a negative exponent on there, we can get rid of that negative exponent, make it a positive exponent by just taking its reciprocal. So x to the negative 2 power is the same thing as 1 over x squared. That's going to be useful. A lot of professors will get upset if you give them negative exponents in an answer. You always want to give them positive exponents. And we can get rid of those negative exponents very easily just by making it into a fraction. So anyways, with this trick in hand, let's go back and let's simplify this expression. Well, that first term, the 0.4 divided by 0.6, that's easy. That's just a fraction right there. That's 2/3. You know, multiply both the numerator and denominator by 5. We can get rid of that one pretty easily. Let's do the second one, though. Let's do all of the x terms. So I have x to the negative 0.6 power divided by x to the 0.4. Dividing fractions, that's just x to the negative 0.6 minus 0.4, or x to the negative 1 power, or just 1 over x. So I took that and I simplified that to a term that doesn't even have an exponent, and that's about as good as you can get. That's going to be really useful for doing algebra later on. I can do the same thing for the third set of terms for the y's. I have y to the 0.6 power divided by y to the negative 0.4 power. So that's y to the 0.6 minus negative 0.4, which is the same thing as adding 0.4. So I get y to the first power, or just y. And again, I got rid of all of those exponents. And so it's just y. So that's really nice. So I can take this big expression right here, put it together, simplify it, and that simplifies to negative 2y over 3x. And that is much easier to work with than that original one I had. And you're going to find that if you work with Cobb-Douglas utility like what we have right here, that's going to be a common result, that you can simplify those expressions incredibly, which is why we like to use that kind of utility in the first place. So as a quick pointer, when you're working on an analysis of a problem, if you can take a few moments to simplify it, it's going to make your steps down the road much easier. So always look for those opportunities to simplify. Anyways, that's all for this video. Thanks for watching.